number 7. We're going to take the integral of negative 12 t to the negative 2.5 dt. I'm going to go ahead and separate it. Integral 7t to the minus 1 dt. So I'm going to do these separately. Of course, these constants could have been brought in front of the integral symbol, but it's not required. The first one I can use the power rule on. So remember, we're doing the opposite of what we would do if we were taking the derivative. When you take the derivative, you multiply by the power and you take 1 from the power. Well, here we're going to add 1 to the power. And instead of multiplying by it, we're going to divide by whatever that power is. So that's going to give me a negative 12t to the negative 1.5 divided by negative 1.5. So I'm going to go ahead and do my division. Negative 12 divided by 1.5 is 8. So this is 8t to the negative 1.5. Now I'm also going to remember my plus c down here. Now this one is different because you can't add 1 to this and divide by it, because look, if I do t minus 1 plus 1 divided by minus 1 plus 1, that's dividing by 0. So what you have to do here is recognize that this is the natural log. Remember that when you took the derivative of the natural log of x, you got, when you did the derivative with respect to x of that, you got 1 over x. So 1 over t, or t to the minus 1, is just going to be the natural log of t. So this is going to be minus 7 natural log of t. And we do need to put the absolute value bars here because we're saying that our original function, natural log, t has to be positive, because you can't take the natural log of a negative. So our final answer is 8t to the negative 1.5 minus 7 natural log, here's your absolute value bars, of t, and you can't forget the plus c. Now here's another one where you have to remember what we did. When we had e to the u, we multiplied, remember, the derivative with respect to u of e to the u was e to the u times the derivative of u, the exponent. So we're going to have to divide by that derivative of that exponent. So the rule says this: the integral of e to the kx dx is going to be 1 divided by k, because the derivative of that would be k, times e to the kx. And of course, that's going to be plus c. Okay? So when we get ready to do integral 4 e negative 0.8x dx, means we've already taken the derivative. So that's going to be, here's our 4 that's already here. Okay? We're going to have to divide by negative 0.8 and multiply by e to the negative 0.8. And there should be an x right there. E to the negative 0.8x. Now, to make sure this is right, just reverse that and take the derivative. If you take the derivative, see, if we were taking the derivative with respect to x of negative 5 e to the negative 0.8x, we would do e to the u, we would negative 5 e to the negative 0.8x, and then we would multiply by negative 0.8. And see, this negative times this negative would be a positive, and 0.8 times 5 is 4, so it would be 4e to the negative 0.8x. We always have to remember to add our c also. So it's going to be negative 5 e to the negative 0.8x plus c. Number 9, the integral of 9x plus 2 squared dx. There is a way to reverse the chain rule, but we're not ready to do that yet. So what we're going to do is we're going to do 9x plus 2 times 9x plus 2. So that's going to give me 81x squared plus 18x plus 18x plus 4. Or the integral of 81x squared plus 36x plus 4 dx. So I'm just going to do each one. I'm going to do 81x2 plus 1 divided by 2 plus 1. 36x1 plus 1 divided by 1 plus 1. 4x plus c. So that's going to be 81 divided by 3x cubed plus 36 divided by 2x squared plus 4x plus c, 27x cubed plus 18x squared plus 4x plus c. That's my original function, of which we had taken the derivative and gotten this 9x plus 2 squared. So 27x cubed plus 18x squared plus 4x plus c. So here's the third one that you don't use the power rule on, okay? The integral a to the x dx. Now notice the base is a constant this time. Is a to the x over the natural log of a plus c. So if I'm doing the integral of 6 to the x dx, it's going to be 6 to the x over the natural log of 6 plus c. 6 to the x over natural log of 6 plus c. So this formula you need to remember. Also remember integral of e to the kx dx is 1 over k e to the kx plus c. And the integral of x to the negative 1 dx, or 1 over x dx, is the natural log of the absolute value of x.